behalf of Dada Patil Mahavidyalaya and Department of Mathematics, I welcome you on this online lecture series. Okay. In this academic year, there are two semesters. In the first semester, we are going to learn two courses. First is algebra and course number 2 is calculus. Paper number 3 is for practical, mostly practical based on Maxima software. Okay, it was introduced in the last year. So we can solve many algebraically and application on Maxima software. But first, we are going to see what is the content in these two courses. So first, sets, relations, and functions. This is the first chapter in algebra courses. Number 2, divisibility theory. Divisibility theory. Theory in integers. Integers. Number 3, prime and residue classes. Congruence classes also there. Classes. And last number 4, complex numbers. Complex numbers. In calculus, first chapter is real number. Number 2, sequences. Number 3, limit. And number 4, continuity. So 4 chapters in algebra and 4 chapters in calculus. So in first chapter, sets. All of you know that what is set? Set is nothing but the collection of well-defined objects. There are some standard set, that is natural number set, integer set, then rational set, irrational, real number, and then finally what? Complex number. Then relations. We know that there exists a relation between two sets. If your set R is a subset of a Cartesian product of A cross B, then we can say that R is a relation from A to B. And if R is a relation from A to B and it satisfies some condition, if there exists for every element belongs to set A, there exists a unique image in set B, then we can say that that relation is a function from set A to B. Then there are some types of the function, 1-1 function, onto function. If it is 1-1 and onto function, then we can say it is bijective, and if it is bijective, then we can find its inverse of function. So that this part we are going to study in our first chapter. In second chapter, in next chapter, in divisibility of theory of integers, here we are going to see some properties of integers. What is an integer set? It is 0 plus or minus 1 plus or minus 2 plus or minus infinity. So there are some relation properties of integer. For example, when we say a divide b, आपण कधी म्हणू शकतो की 2 हा 4 ला डिवाइड होतो. If 4 is a multiple of 2 and if a divide b, b divide c, then a divide c, then there is GCD of integers, then LCM of integers. Okay, and there are two Euclidean theorem is there, GCD theorem is there, that we are going to study in theory of integers. Now next, in third chapter, we are going to study the prime and residue classes. All of you know that of prime numbers. Then there are some properties of prime number. Euclid lemma is there. If P divide AB, then either P divide A or P divide B. जर P हा prime number असेल आणि prime number हा दोन नंबरच्या प्रोडक्टला जर डिवाइड करत असेल तर तो एकतर A ला तरी डिवाइड करेल किंवा B ला तरी डिवाइड करेल. त्यानंतर रेसिड्यू क्लासेस, नंतर आपण बघणार आहे कॉन्ग्रुएंस क्लासेस. त्यामध्ये आपण बघणार आहे की A रिलेटेड टू B और A is congruent to B modulo n if n divides A minus B. So these are the two new chapters for you. Divisibility theory in integers. This course are completely a pure mathematics course. This is also pure mathematics course. Applied mathematics course we are going to study in second semester. These two courses are pure mathematics course. So residue classes are there that we are going to see in third chapter, complex number. Okay, all of you know that what is a complex number. It is also form A plus IB. A plus IB. I is what? Under root of minus 1. So again some algebra of complex number, that is Z1 plus Z2. Then mod of Z, we can find argument of Z. Then we can find addition, multiplication of complex numbers are there. So these are details we are going to see in chapter number complex number. Okay. Then roots of complex numbers are there. Nth root of unity and region of complex plane. This theory we are going to see in complex number chapter. Now next, here in calculus again there are four chapters. A real number. All of you know that what is a real number? It is a union of rational and irrational numbers. But there are some properties of real number. Again, algebraic properties are there, order properties are there. That is, when we say that, जर मी तुम्हाला सांगितलं if A less than B, then what is the A plus C and B plus C? If C is positive, then what is the relation? If A less than B, then what is the relation between A plus C and B plus C? So these are some order properties of real numbers are there. Then next, absolute values of real numbers we are going to see in the chapter. What is absolute value? What is mod of x? It is equal to x if x is positive and minus x if x is negative. So mod of x is always a positive, greater than 0. Suppose you want to evaluate the mod 2, then it is 2, but minus mod of 2 दिला असेल, then we can multiply it by having minus sign. So minus become plus 2. So but again there are some properties of absolute value, that is mod of AB is equal to mod of A, mod of B. And important property is what? If mod of x is less than A, then your x is always less than minus A, less than x, less than A if your A is positive. So these are some properties of absolute value we are going to study. Then archimedean properties there, then completeness properties is there. Then again important is what? Supremum and infimum of set. Okay, bounded set, upper bound, lower bound we are going to study in real number sets. For example, if this set is given 1, 2, 3 or 1 by 2, 0, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and so on. Then what is an upper and lower bound? If you observe, all the numbers are greater than or equal to 1 or less than or equal to 2 or 1.1, 1.2. So they are all upper bound for this set. Now what is the lower bound? So this lower bound is what? 0. All these numbers are greater than or equal to 0. So 0, minus 1, minus 2, they are all lower bound for this set. And then next we want to determine the greatest upper bound, greatest lower bound and least upper bound for this set. We can say it is supremum and infimum of set. Now next, sequences. Again a definition of sequences, then convergence of sequence. When we say that the given sequence is convergent or divergent of sequence, we are going to study. There are some tests to check whether your sequence is convergent or divergent, limit test. Okay. Then next, after that we are going to study limit. Okay. If you know here algebraic sequences 11th and 12th class में study किया है, but here we are going to show that limit n tends to infinity. Suppose an is equal to n, आपण हे प्रूव्ह करणार आहे की an चा आपण लिमिट फाइंड नाही करणार आहे. दिस इज नॉट आवर जॉब. हियर वी आर गोइंग टू सी the limit of an is L, and for that we are going to use the epsilon delta definition. Okay, or epsilon definition. When we say that this is the limit of L is the limit of sequence an if your an minus L is less than epsilon for every n is greater than or equal to n0. मी तुम्हाला कोणता epsilon दिला तर तुमचं लिमिटचं आणि an चं जे काही डिस्टन्स आहे ते epsilon पेक्षा लहान असणार आहे for every n belongs to n0. Similarly, okay, we are going to study in sequences. Here limit of function. Again, if you understood the definition of epsilon in the chapter sequences, then the limit is very simple. Limit definition is again simple. Okay, instead of here only n0, we write here mod of x minus a is less than delta. Okay, delta neighborhood, we can say that. Okay, so again there are some properties of limits. There is sandwich theorem is there. Then if the limit of f is L, limit of g is m, then f plus limit of f plus g is L plus m, limit of f g is lm, limit of f upon g is L by m. These properties we are going to study in the chapter of limit. Now next, continuity. Okay, so when we say that the function f is continuous, if there is no break in a graph. Okay, suppose if you consider this function, this is the step function, all of you know that this is not a continuous function because there is gap in a function. Okay, so this is not a continuous function. Again, suppose these two functions, they are again not a continuous because there are some gap. But if you join these two graphs, okay, then when we can say that this graph is continuous at this point A, if the left hand limit at A is equal to right hand limit of A. If this जर ह्या ग्राफचं या फंक्शनचं लेफ्ट हँड लिमिट आणि या फंक्शनचं राइट हँड लिमिट जर इक्वल असेल तर दिलेला फंक्शन तो दिलेला हा जो काही ग्राफ आहे तो कंटिन्यूअस आहे at x is equal to A. So definition is very simple. If limit x tends to A, f of x is equal to f of A, then we can say that function f is continuous. Again, जर function continuous असेल तर there are again some properties of continuity we are going to study in chapter continuity. So hope you understood. In the next lecture we want to start our first chapter, sets, relations and function.